Hello, today we'll see about the concepts of limit. So we'll just talk about the precise definition of a limit. So now we are just going to guess the limit for this function, limit x tends to 1, x minus 1 by x square minus 1. So let us consider this function as f of x, which is going to be equal to x minus 1 by x square minus 1. Now it is very clear that at x equal to 1, f of x is not defined. However, what is the meaning of limit here? Limit of a function f of x states by definition when x tends to a, f of x tends to the limit. Okay, so we can say that when x is very closer to a and not equal to a, then f of x will approach its limit. So now we can see from the table there are some values of x lesser than 1 and it will give the values of f of x which is approaching the limits, and there are some values of x greater than 1 which is approaching the limits for f of x. Right, now you can see for x equal to 0.5 it is 0.66667, for x equal to 0.9 it is 0.526316, and x equal to 0.99 it is 0.502513. Like that it goes. When you increase the values which is going to be very closer to 1, then you will be getting 0.50025, which is almost 0.5. When you see in the other side here, when you take 1.5, then f of x approaches 0.4. When you reduce it, that means when you are closer to 1, like 1.1, it is becoming, the value of f of x becomes greater, and 1.01 it is 0.49, 1.0091 it is 0.499, and 1.0001, actually it is 1.0001, it will be 0.49975. So you can see these two values which are very closer. 0.9 is going to approach 1 but not 1. Here also 1.0001 is almost going to approach 1 but it is not 1. So the value of f of x will be approximately 0.5. So in both the cases, when x approaches 1, f of x approaches 0.5 approximately. So that is the meaning. Right. Now, when you talk about this limit, actually, how do you obtain the answer? So here I told it is directly 0.5, as we know from guessing the values of x which are closer from the left hand side to 1 as well as right hand side, it approaches to 1. By basic algebra, you can see when you just expand this x square minus 1, it will be x minus 1 by x minus 1 to x plus 1, which will be 1 over x plus 1, which is 1 over 2, which is 0.5. So now this again gives the answer as 0.5. Now let us consider a function g. Now how is g? G is defined like this. So when x equal to 1, the value of g is 2. When x is not equal to 1, it is x minus 1 over x square minus 1. Now what is the limit of g of x when x approaches 1? Here the limit is defined as x approaches 1 but not equal to 1, as we know. So when you find that, you will see the value of g of x when x approaches 1 will be approaching 0.5. That means the limit is 0.5. So you have to note that at x equal to 1, the value of g of 1 is 2. So when x not equal to 1, then again you find this g of x to be 0.5. Now why we are talking about this concept is, you can see this first example, we have x minus 1 over x square minus 1 limit value is 0.5, but for x equal to 1 this is not defined, whereas here for x equal to 1 we are just giving some values 2. So it is just taken as 2. Okay, so you should not confuse over here. It is just when x equal to 1, there is a function like this. So even there is a value for x equal to 1, when x not equal to 1, this g of x is going to approach 0.5. So this first example and second example ensures that when x is not defined at 1, we get a limit. When x is defined at 1, we again get a limit, which is going to be same with these functions. Now let us investigate an example for finding the limit x approaches 0 sine pi over x. So let us take f of x equal to sine pi over x. Now the function f of x equal to sine pi over x is not defined at x equal to 0. So as we know, pi over 0 will be not defined. Obviously sine over this not defined value is going to be undefined here. So we have to evaluate that. So evaluating the function for some small values of x we have, for example, let us take this function f of x equal to sine pi over x and just substitute x value as 1. So what will happen here? This become 1, so sine pi is going to be 0. Now let us take 1 over 3 for x, so we will get sine 3 pi. Before that we'll take 1 over 2, it will be sine 2 pi, like that it goes in this way. When you just decrease from 1 to 1 over 2, 1 over 3, 1 over 4, 1 over 10, what happens is the values of sine for all the values of x will be it's going to be 0, you can see, and f of 1 over 10 is again going to be 0. F of 1 over 100, which is 0.01, is going to be 0. So when you reduce the values from 1 and when it approaches 0, then sine value approaches 0. So if you consider it like this, what is the guess here is limit x tends to 0 sine pi over x is 0. But is this true? This is not true. There is some reasons why this is wrong. Here, although we see f of 1 over n is sine n pi, which is going to be 0 for any integer n, it is also true that f of x may be having some values like 1 for infinitely many values of x as x approaches 0. So here we have gone with 1 over 2, 1 over 3, 1 over 4, but for some you can see these values, but there are some more values for which you may get your f of x value to be 1. So that is the meaning. So as x approaches 0, you can see this curve. This is the curve what we can see here, sine pi over x. So when x is going to approach 0 from negative minus 1, okay, and positive plus 1, from left hand side to right hand side, okay, you can see almost this curve is coming closer towards 0, and the thing here is whenever you substitute the values, it oscillates between minus 1 and plus 1, you can see. So this is oscillating like this, minus 1 and plus 1. So we are not going to be sure whether it takes a single value. That means it is just oscillating. You can see this portion, the dashed line near y-axis indicates that the value of sine pi over x oscillates between plus 1 and minus 1 infinitely as x approaches 0. So like this it goes on. You can see this dense area, right? So since the value of f of x do not approach a fixed number as x approaches 0, we cannot tell that limit x tends to 0 sine pi over x to be 0, which is ultimately wrong, okay? Because when you see the graph looks like it's not going to approach 0, but it oscillates somewhere between minus 1 and plus 1. So there is no such limit which is going to be existing for sine pi over x when x approaches 0. I hope this example gives you a better understanding like how we approach the problem, okay, before getting into the formal definition. So I hope this is very clear for you. Thank you.